Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic function graphs, specifically how we can find the intercepts and zeros of those graphs, and we'll do it in 5 minutes or less. So before we can actually find the intercepts and the zeros, we need to define those terms. Let's start with probably the easiest one. That's the y-intercept. And sometimes there's going to be 1. Sometimes you might not get any y-intercept, just depending on how it's built. But we actually have the y-axis right here. It's our vertical axis. This is not necessarily symmetrical with the origin. So we are going to get a slightly off y-intercept there. So that's the point where it crosses the y-intercept. It's not necessarily going to be an integer, but we can make a pretty good guesstimate as to what that is. Right, so that's -5, that's -6, that's -7, that's -8. So it looks like it crosses the y-axis right exactly between -7 and -8. So we can reasonably say, you know what, the y-intercept is going to be -7.5. Sometimes you might get a problem and it tells you that the y-intercepts or the x-intercepts are going to be integers or whole numbers. As in this case, we didn't have that, and obviously it's going to sit right there between -7 and -8. Now the other one is the x-intercept. And the reason I wanted to do that next is because this is one that is known by multiple terms. Sometimes the x-intercept is simply called the x-intercept. Sometimes it's called the zero. And sometimes it's called the solution. But they all actually refer to the same thing. If we were to think about this as a function, we would think, okay, so if f of x equals 0, what is that x value? What is the x value that you need to have in order for the f of x or the y to equal 0? So here we're looking at our x-axis, and we want to know, where does the graph cross that x-axis? Well, we see it crosses at 2 points right here. These two are going to be integers right here. So we see this coordinate is going to be 3, 0. The y value is always going to be 0 of these x-intercepts, since that's where it crosses the x-axis. That's why they're called the zeros sometimes, because we're looking for what is the x value that makes f of x equal 0. So we can say our x-intercepts, we've got 2. It's going to be 3. We can also say it's going to be -5. And if we wanted to give you the actual coordinates, right, we could say -3, 0. We could say -5, 0. Just like this y-intercept, we could say that coordinates would be 0, -7.5. Let's look at another example. So now we have a downward opening or a downward facing parabola. And let's look at the same thing. So first we'll look at our y-intercept. In this case, we do have a y-intercept. And it does look like it's going to be on an integer right there. So that's going to be -1, -2, -3, right there on -4. So the y-intercept is -4. If we wanted to give you the coordinate pair, it would be 0, -4. Now let's look at our x-intercept or our zeros. Now typically in most graphs you will get 2 x-intercepts, but in this case we actually are only going to have 1 x-intercept, because look, it's shifted over here, but once again, here's our x-axis. It actually just touches it at one point. It doesn't even necessarily cross it. It just touches it at one point. So that's going to be our only zero, or only solution, or only x-intercept, however you want to say it, right? So it's going to have the x value of 2. So we can say that x-intercept, or the zero, or the solution, is going to be 2. Sometimes you might get a graph that has no zeros or no solutions. And that would be something, if it's downward facing, maybe it kind of looks like this. It never quite reaches. Or if it's upward facing, right, it goes like that, but it never quite reaches it. So it is possible to get no intercepts. Now you are going to get y-intercepts, because they're always going to expand out and eventually cross the y-axis, but you could possibly get no x-intercepts, no zeros, or no solutions.